I'm going to structure my talk in 3 parts. I'm going to give a brief introduction to the ELIXIR Proteomics community. Then I'm going to talk about, well, the meat of the project, metadata annotation of public proteomics datasets. And then I will end with highlighting some perspectives for the near future. Okay, so first slide, since I didn't know if who was going to join this webinar, I thought it was a good idea to add a general introductory slide about mass spectrometry-based proteomics, which has a lot of applications these days, measurement of proteomes in time and space, protein-protein interactions, post-translational modifications, protein localization, etc. And I'm sure that most of you are aware, but just to highlight that mass spectrometry is really the main analytical technique that is used today in high-throughput proteomics. There are others, like antibody-based approaches, aptamer-based approaches, but mass spectrometry is by far the most popular approach. And mass spectrometry has been really the focus of the ELIXIR Proteomics community. We started, I think it was like 4 years ago now, in 2017. And if you want to know more about who is part of the community or some of the objectives of the things that we want to do, you can see this paper in F1000. Just to summarize, in that paper, there were we highlighted like 3 main areas of interest for the community. Area 1, multi-omics integration. Area 2, reproducible open analysis pipelines. And area 3, data management and annotation. And this is really the main focus of this implementation study and about everything that I'm going to be talking today. In this context are topics involved like management of human identifiable data or data improvements or data standards in general. Okay, so also for those of you who don't know much about proteomics especially, I have to introduce what PRIDE is. PRIDE is basically the world leading resource for storing mass spectrometry-based proteomics datasets. Is based in the EBI, European Bioinformatics Institute. It stores mass spectra, for instance, raw data, peak lists, peptide and protein expression data. All proteomics approaches are supported. Currently, there are more than 21,000 datasets. And we get data from more than 8,000 submitters and 60 different countries. So PRIDE is good in the sense that it's a European resource and is, as I said, by far the world-leading resource in the domain of proteomics. So PRIDE is not working in isolation. I wanted to highlight this as well. We are one of the founding members of the ProteomeXchange consortium that tries to standardize data submission and dissemination practices between the main proteomics repositories. PRIDE is here in the center, of course, in Europe, as I said, and then there are 3 resources in the US and 2 in Asia. And thanks to the push from funding agencies and journals and the open science drive in biology, data sharing has really generalized in the field. So the next slide, I show basically how data in PRIDE keeps growing. So PRIDE started in 2004, but and in this chart, you can see the number of submitted data sets per month. This is not cumulative. This is basically data that gets submitted per month. And just in the last year or so, we have experienced another like 40% increase in submitted data sets. The peak we reached in June last year with 566 data sets. But this, again, for everyone in proteomics, also in other fields, saying that there is a huge amount of public data available, an average of 450 data sets per month in 2020, a total of 5,300 data sets. And PRIDE stores, again, like 83% of all ProteomeXchange data sets. Of course, the point of storing these data sets is really not just storing data per se, is that, to enable data reuse by other members of the community. This chart shows the volume of data downloads from PRIDE from 2013, when we started measuring this, till last year, 2020. And as you can see, last year there were like 1.4 petabytes downloaded, which really shows that the community is embracing data reuse for many different applications, proteomics, post-translational modifications, meta-analysis in general, spectral libraries, and many others. Okay, so after this introduction that I thought it was needed, especially for those of you who are not that expert in proteomics, I'm going to talk about basically the reason behind this project and what has been achieved so far. The existing problem in Pride as a representative of all the ProteomeXchange resources is that for all public datasets, I have some before, there are really a huge amount of data that gets submitted every month. There is information about the data set, general description, information about the submitter, the PI, for instance, data analysis protocols, and I don't know, post-translational modifications, instrumentation, etc. And on the other hand, we have also the data files, especially in the case of submissions to ProteomeXchange. The raw mass spectrometry data coming from the instruments and the process results files are mandatory, although there are other data types that can be included optionally. And this is all supported by for instance, the current Pride standalone submission tool. So this is what is there right now, but what is really missing is this relationship between the data set and the different data files that are contained in that data set. So for instance, information especially about the samples and the experimental design. That doesn't mean that there isn't anything at all. So what I mean here is that structured metadata to link individual files to sample characteristics is mostly missing. Very often this information can be inferred, for instance, based on file names or in other characteristics, but of course, this is far from ideal, and this is what we want to change. And of course, this is not the state of the art in, I don't know, resources like similar to Pride, like for instance, analogous to Pride, like for instance, ArrayExpress for transcriptomics data. So we started working in a project that the first step was to, the main objective was to define a file format that could record sample-related metadata and experimental design. The requirements that were compiled were to support, being able to support sample characteristics, again, to record sample characteristics to files, that it should be easy to use by submitters, manually annotated, or also that could be generated by software tools, should be compatible with existing data formats in proteomics, like the ones that we use internally in ProteomeXchange or other proteomics open data standard formats like MAGE-TAB, NCR-NTML, or MCML. The idea was also to make use of control vocabularies or ontologies where possible. And that, of course, although the first interest was to apply this to Pride, it could also be applicable to other resources as well, to the community as a whole. So this project was started quite a long time ago now. I think that's 2.5 years ago, or even more, as part of an ELIXIR implementation study that ran for 2 years, entitled Crowdsourcing the Annotation of Public Proteomics Datasets to Improve Data Reusability. And there were 10 ELIXIR nodes involved, and I'm not going to name every single person that was involved, but you can see them here. So basically, what's taking into account the requirements that I mentioned before, we thought that it was not a good idea starting from scratch. So we wanted to reuse something that had been already developed before and adapted for the proteomics requirements. And that's why we decided to go for the MAGE-TAB kind of framework that basically is composed of 2 different files, as I will mention in this slide, but also is a format that is well known in the transcriptomics community, and this could enable also multi-omics studies in the future. Also, to be honest, because we were coordinating the project, we had the colleagues that were experts in this format just in the same corridor, so it was also easy to talk to them. There is already existing tooling to validate and create the files, and also there is ongoing work to represent even more complex cases that are not that relevant in proteomics today, but will definitely be more relevant in the future, like for instance, single cell RNA-seq experiments. And of course, it's a that delimited format, which makes things easy to generate and compatible with existing tooling proteomics like MSTATs, among others. So I want to basically mention that MAGE-TAB, again, this was developed by the functional genomics team in the ABI originally many years ago. They are responsible of ArrayExpress, which is the equivalent resource to PRIDE, but for transcriptomics data. And also they're responsible for expression numbers. MAGE-TAB has two parts. The part that is called IDF, Investigation Description Format, and that is basically the bit that describes the experiment. As I mentioned before, we already have this because this information is already collected in current submissions to PRIDE. So actually it is kind of straightforward to do a conversion for the format that we use today that we call PXXML to IDF. So the second part of this, and this is really the bit where the relationship between samples and the data is recorded, is so-called sample and data relationship format, or SDRF. So we decided to develop a new flavor of this SDRF format that we would call SDRF-Proteomics, and that would support, apart from RNA-seq and microarray approaches like it is happening today, would support also proteomics experimental approaches. So this work has not been led by me, has been mainly led by Josep Rivero, so he's the coordinator of the proteomics team at the ABI. And since the project started, he has handled it in a kind of very open way and very practical way, I think, making use of GitHub. For instance, all the issues related to the format have been discussed openly there, although especially in the last months, there have been also some conference calls as well involving colleagues from, for instance, other ProteomeXchange resources. So everything that I'm going to say is just highlights of a format is already there and is already quite kind of mature. It's still not fully formalized as a standard. It's a process that is ongoing. But if you want to read, all the documentation is available in that GitHub repository. I just added there like 2 screenshots to highlight that, again, the documentation is already quite mature. So I'm just going to give some highlights about how the format is structured. Again, it is designed in a way that is compatible with the SDRF format that has been already available in the transcriptomics field for a long time. So the format has 3 main different sections. One that is devoted to sample properties like source name, characteristics, organism disease, phenotype. Then the other section is devoted to data file properties. Another section that is devoted to study variables. So sample properties are those attributes related for the sample, like again, tissue, disease, etc. And the sample properties are annotated with the prefix characteristics. Then we have the data file properties, like for instance, mass spectrometry focus information, like information about the MS run, fractions, levels, etc. These properties are annotated with a prefix comment to make it compatible with the format, the original SDRF format. And then we have also study variables, where the variables under study can be represented. And the study variables are annotated with the prefix factor value. Some more kind of highlights of the format is that the column names must have an existing name available in an ontology or a control vocabulary. Like you can see here some examples. But the values can be CV terms or ontology terms, but also free text. And also there's some more complex information that needs to be represented as complex key value pairs, and this is unavoidable. And this is actually the way some proteomics specific information has been encoded. The kind of example that is we could highlight here, but there are others. Is the annotation of post-translational modifications, and there are different kind of keys that are applicable to different characteristics, like for instance, name of modification, database accession, chemical formula, etc. And then again, there is a key and a value, and some of them are mandatory and some of them are optional. Okay, so I'm not going to give more details about how the format is kind of defined or structured. Again, all the documentation is available in the GitHub repository, and you can go there and see all the details, because again, as I mentioned, I think that the format is already quite mature and well documented. Something that is key is following the what has been done before in transcriptomics, is the existence of sample templates that people can use as the base, for instance, using Excel to create SDRF proteomics files. And there are different templates that are also available in the GitHub repository. So, so far, also in the GitHub repository, there are more than 180 datasets annotated. They have been really annotated by different groups in the community, and again, not only in Europe, also in Asia and in the US. And they are kind of represented there, the main proteomics workflows, like quantitative proteomics, both level 3 and label approaches, PTM-enriched datasets. Also, the first DI datasets have been just annotated. There are also only identification-based experiments, etc. So the main, really, the approaches have already working examples there. Okay, so in parallel, we in Pride have been working in providing at least some support already for SDRF-Proteomics MAGE-TAB. So as I mentioned before, in the case of IDF, which is again the file containing all the dataset related information, we don't really need to do anything else apart from adding a step in our pipeline that enables the automatic conversion from the existing format that we have to IDF. So so that's invisible for the users, obviously. But then what has been done is two things. One is the price submission tool. As I mentioned before, it is now possible to submit SDRF proteomics files. Or also, what it is also possible is to annotate and annotate those data sets and make them available in a GitHub repository that I already mentioned. In both cases, this is taken automatically by Pride's internal pipelines. And then now we are making use of a resource in the API that is called biosamples. That what it's able to do is to register samples and provide unique identifiers to samples. And this is already happening. And then what is also happening is that the SDRF information is rendered in the Pride web. And this is one example of one of those 180 projects that are now kind of already annotated using SDRF. This is a very famous dataset in proteomics, one of the drafts of the human proteome. SDRF file has been created for that, and again is now rendered and available from Pride web for everyone to use. At the moment, submission of SDRF files is optional. As I mentioned before, biosample IDs are provided, and of course, what we want to work in the coming months is how to make possible to submitters that this information, again, the mapping between the dataset characteristics and the data files, can be submitted the submission can be made mandatory. So for that, we have the templates that will continue to be improved. In this case, users can download them and edit them manually in Excel. This is difficult. This is something that It requires some learning curve, obviously, but it is definitely possible. People are very used to work in Excel, and then it is possible to validate the created files using an already validator that has been developed by JustSet. And in parallel, what we have been working in is in a web tool to support the creation of the SDRF-Proteomics files and what we could call a web annotator. Jingwen Bai from the team has been working on this for quite some time. A first version of web annotator has been developed, but actually it is a quite complex tool among many reasons, because potentially many files can be included in a single data set, and this makes this tool difficult to, it is difficult for an annotator to be able to manage well, a large amount of files. And at the moment it's still currently being assessed internally in the team, but it's not publicly released yet. We still have to make it work in the way we would like before making it publicly released. Okay, so just to finalize, just with some perspectives from the future, that how this work will continue. And again, to highlight that tools and software to support SDRF proteomics are under development. At the moment, the submission of these files to PRIDE is optional. The next step for us will be to make it mandatory for particular subsets of the submitted datasets that we have to decide exactly which ones, because again, we are receiving now on average 450 datasets per month, and we need to be able to cope with that kind of data flow. So we have to again come up with the right strategy to make this file mandatory. And we also want to highlight more those well-annotated data sets for users that spend the extra time doing that. We expect that the existence of this format and the annotations will facilitate data reuse of public proteomics data sets. That is basically what we all want to achieve here. And for instance, the easy integration of quantitative proteomics data sets in expression atlas, because again, as I mentioned before, we are using the same formats that they have been using for many years. And also, it will facilitate automated reanalysis of data sets, because I haven't mentioned that, but in addition to sample-related information, SDRF-Proteomics can also store analysis parameters that are used for the proteomics analysis. The information is, of course, optional, but it can be used to store that kind of information. And if that information is available there, that definitely will facilitate automated reanalysis of data sets in the future. And there is a new ELIXIR implementation study that has just been approved to keep working in this overall concept of further development of SDRF and its use for enabling automatic reanalysis of data sets. Okay, so this is, I promise, my last slide. SDRF proteomics format has been developed to support an urgent need of the proteomics field. It is, at the moment, is in the process of being formalized as a standard. This addresses one of the main work interests of the ELIXIR Proteomics community in the context of data management. We hope it will facilitate data reuse of public proteomics data sets and the extraction of new knowledge. That's the whole purpose. And again, an ELIXIR implementation study has just been approved to keep working in this overall concept. Of course, I need to finish with the acknowledgements. This is the list of everyone in that GitHub repository that has been involved so far in the current version of the work there. Especially, again, I have to highlight that JustSet has been in this work. And also from my team at ABI, Jingwen, Chakra, and Selva have been contributing to that technical infrastructure to support SDRF, and also Dipti and David have been already creating some data sets. And also, I want to highlight everyone involved in the implementation study that, again, I haven't really named, but all of them are here, and also some ProteomeXchange and Proteomics Standards Initiative colleagues. And that's it. So I'm open to questions.